Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellyn, Illinois. And this video today is going to be looking into a homework problem that you guys, or activity problem that you guys have for Advanced Plus. And we're just doing the tinkering with STL lists. So we're just doing a lot of little things just to kind of get ourselves acclimated with the API that the standard template library allows us for a linked list. And so here is, I just basically copy pasted the thing from everywhere else, and so, or from the homework assignment on Blackboard, and we're ready to go. The first item of business here is to create a function called printlist. I can spell already, printlist. And what I want to do is pass in, since I just want to print, I do not want to modify the thing, so I should pass this thing along, and we're doing everything by int today, so I want to pass this thing by const reference so I don't have to make a copy of it, because I just want to, you have read-only access to go through the whole thing and print out element for element. And so I can I'll just call this, I'll call it giant big L. Maybe it's a terrible name, maybe it's not. But what I want to do now, for every item in this list I want to print, I can use a range-based for loop. I don't have to do anything silly with this thing. I can just say, for every int I in giant L, cout I, and then add a space. And then let me, just for the sake of my own sanity, let me put the curly braces in. Space separated manner, and yep, okay, and we will use this. I'm fairly confident this thing is going to work, so I'm just going to eliminate this. And let me just create this one here, and then we can see, whoops, comment. I didn't want to do that, never seen that before. So I can say ste list int, I'll just call it A, is equal to, or if you don't have to put the equals necessarily, I can, look at that, I can, something like that. And then what I can do, and just, it doesn't necessarily say this here, but I don't want to have to do it all the time. I'm just going to put a end line here. And then what I can do is print list A. And let's just see what comes up. And there I go. So that my print function is working properly. I can pass this thing in, and no matter how many elements this thing has, it'll print them all space separated. So yep, I'm good with that, and I'm good with this level of understanding as well. Okay, so for the next thing to do is basically the same exact thing. Create a, oh man, this commenting is crazy. Come on, oh, one too many this time. Create a list B that essentially does everything in reverse. There you go there, print out B, and then reverse. Like if I went to go B dot, and I said B dot, and I say B dot, let me find something here. Erase, and you can see there's two different ways I can use the thing. If I want to do reverse, you can see there's no second choice. It's an all or nothing thing. I either reverse the entire linked list, or I reverse nothing. And so that's just the way things go, and I'm going to do that. And now you can see that A and B, they have different copies of the same values, but you can see that, you know, at the end of the day, this row, and this row are identical, because all I did was reverse manually and then reverse automatically using code. Okay, so continuing forward, I want to create a list K, which initializes a copy of every element using the copy constructor. So I don't think we've alluded to this just yet, but we might have. So I want a list of integers. I'm going to call it K. And basically, if I'm going to copy A using the copy constructor, that's it. There you go. And I can print this K. One thing I could do, let me just do this here, just real quick here, is I can pass along a character for, you know, the whatever it is that I'm going to be printing out. So just to make it so we can actually see things a little bit easier, and I can just go ahead and cout, I can print out this X character with a space. And so it's going to blow out everything here, but I can just go ahead like this real fast, set everything up. Oops, let me put a colon, X colon, enter here. And so that we'll be able to see everything like we're supposed to, and it'll come out nice. And so far, so good here. So let's, okay, so let's try, oops, I didn't put a comma here. Okay, so let's try this. Oops, destroy and destroy. And so now you can see this. Oops, I have another error somewhere. I might have another error. Where am I? Here, oops, I didn't put a comma in a couple places. Okay, there we go. And now you can see A, there's my A, there's my B, there's my B, there's my K. And so K used A and basically copied that. And the other way we can do this when we're setting up this one M is that using iterators of B. So just M, and so this one says iterators. So I want the whole thing. I say get me from begin to end. And I want to print out M. And now that should do exactly the same stuff. There we go. And so B, A and B are identical, so yeah, you'll get the same results. But again, remember, every one of these lists is maintaining a separate copy. They're not all pointing to the same memory locations, and if I change one, I change them all. All of these have separate memory for every element inside of their collections. Okay, so merging list M into K. So it's easiest saying k.merge, and you're just like, oh goodness, there's 4 different ways to do this, and I can just say, give me the entire list, and I can just say M. I could say m.begin, m.end. This is just to show you if you wanted to do regions, you wanted to merge just a region from point A to point B. Oh, is it not going to let me do this? Oh boy. Okay, maybe it's not going to let me do that. I don't have my fancy book with me, my Jasudas book. I'm staring right at it. It's all the way over there, but I'm not going to get to it right now. So let's see. I can. What do I have access to? Everything has to be an all or nothing thing again. I guess I'm not allowed. To me, it would make sense to allow that, but oops, k.merge M. But it's okay. And now what's interesting here is you're like, well, when I merge, I'm not making copies of the thing. I am actually taking everything inside of one of them and merging it in, and so one of them gets filled up with both things, and then the other one doesn't. And so here you go, and it looks like merge has to, because it's like a merge sort. You're presuming that you have a sorted list and you're putting a second sorted list in, and notice how it merged everything, and it basically sorted everything while it was going. What would happen if I didn't do that? What if I put like let me see, K, yeah, let's see. If I put something that's out of range in here, it probably crashes or doesn't compile. There we go. The sequence is not ordered. You actually get a runtime error if you're not if merge is dealing with stuff that's unsorted. So you got to watch out for that. You have to. There's no way to know these things outside of just the experience of reading up and just knowing how these things work. Okay, so let's see. So that's that. So now I can just say, oops, oh my god, this thing. What do I want? How would I go ahead removing the duplicate elements of K? I believe the function is called unique, and I do not require anything to do this. So now, if I take K and I get out and I remove all the duplicates, and again, this is all it's looking for is just if 2 of them are together, because remember, unique is looking just, like little neighbors here. Is a neighbor the same on one end and the other? And it removes one of them. And we're right back to where we were, because we have 12 elements. There were 12 elements, but they were all duplicated, as you can see. And now they're all removed. And so just to say here, if I did go ahead and insert and I figure out where I have to insert and what am I going to insert, and I say k.end, and I can insert a 5. And then I can insert a 15 and a 5 again. You can see that all it's really doing is looking to its neighbor. It's not looking out throughout the entire thing trying to see, oh, is there one anywhere? Nope, it's just neighbors are getting removed. So you're snipping out. So that's why the 5s stick around even though there's a 15. Just all of this to come back. Get rid of that unique and bring it back here. All right. And now we're ready to move on to the next part of this. Okay, we've done this before. We know. I've never seen that before. Okay, so to create a list D, which basically takes A. And I say we've done this before. We've done this. We're just copying this, getting this ready just for practice. And so now I want C. Got D that does that, and then I got C that uses iterators of B. So there you go. That's done. Getting closer. Now the harder stuff is starting to come, or not just after this one anyway. So if I want to create a list, I should probably, just for the sake of this, I'm all over the place today. Copy D, copy C, print out C. Okay, so now I want to create another list of integers. And I wanted 7 elements all initialized to 9, and I can do that. 7, 9. Using that initializer constructor. Go. So you can kind of see everything. There's copy, copy, copy. 7 elements, all the number 9. And so now we're getting closer to the end. Now things are going to pick up a little bit because now we're going to use more complicated paradigm. All right, so the next one, set up the first 30 numbers and their squares inside of a list. So I can go ahead and do that. Set up a list. What am I calling it? F. There's no way you can do this in one line of code. You're going to have to physically go ahead and do a loop. So for int, just making sure I'm not using I. I don't think I'm using I for anything so far. So int I equals 0, I is less than 30. Oh, sorry, I gotta start with 1. So I is less than or equal to 30. Plus I. And I could do f.insert. Insert into the end, the back of the list, f.end, I times I. There's no reason to use power. There's no reason to just not use a simple multiplication to do the job. Let's make sure that's working for us before we worry about the other parts. And there we go, from 1 to 900, from 1 squared to 30 squared. There are all of the elements inside of that list. And now we're ready to use these more complicated algorithms to do the job of eliminating just the odd values. Because what would you do? You would set up a loop, and you would go, oh my goodness, is this an odd number? Then you would erase it, and then you'd keep on going. It sounds complicated. It is complicated, but the standard template library is there to help us. So the stable partition will go ahead and apply a rule, basically a true-false Boolean predicate, I think is what the name is. And what you do is you just go, hey, is this value odd? And you go, and it'll just say yes or no. And then the stable partition will move them. And stable means they'll keep them in order, left to right order. And on the like inside of their partition, and there's going to be a place where the partition ends between the two partitions, because it's going to set up the true condition and the false condition. And on the left-hand side, all the things that are true are going to be placed there. And then on the right-hand side, everything that's on the right is going to be placed there. And like, what the hell is Brad talking about? So let me just do this, and you'll be able to see it here in a minute. Let me just see what stable partition. What does that return? It's been a while. An iterator. And what the iterator returns is the place where the trues end and the falses begin. And so what I'm going to do here is I just want an iterator. I want to store this thing just for the moment. And so, okay, so I say, okay, give me a stable partition. And so, is it not happy because of... No, it's just because I haven't finished it up yet. Okay, so I want to go ahead and go through F, all of F. And this modifies F. I don't know if this is completely obvious. It's returning an iterator, so, so what else is it doing? It's modifying the list under the hood. And so what we can do, there are many ways we can do this. And so we can set up a function, because this is the third parameter of this thing, the predicate. And it's just a bool function. And I can set this up here. Let me just do it the easiest way. Bool. And I can just call it is, let's see, which one do I want? I want to, we'll just say is, no, wait, hold on. I want to, whatever's true. I want to eliminate the odd values. So I'm going to say is odd. And an int comes in. And all I'm basically going to do here is just say, hey, is odd. Something like this. If I take it and I look at the last bit in the value, and I AND it with 1, the result will either come out as a 0 or a 1. If it's a 0, it's even. If it comes out 1, it's odd. And I'm trying to do is odd. So x and 1, is it 1? Yes or no? And that's all I need to do. And then I can tell it down here, supply that function. And I don't have to put any parentheses in here. Isn't that weird? But that should do it. So let's see what happens. Now you can see all of that hard work there says go through the entire F and put all the odd numbers on the left. And you can see all the odd numbers are on the left up to this point right here where the 4 is. And then all the even numbers come after. And then what happens is this iter is pointing to this guy right here where the 4 is. Because that's where the first partition ends and the second partition begins. And now if you want to 2-line it, you could even 1-line this if you wanted to. It's because the whole point is to eliminate all the odd values. Oh, I did do it reverse then. Or maybe not. It doesn't much matter when we're working with linked lists because deleting from a linked list, it doesn't matter if it comes from the beginning, the middle, or the end. It's going to be the same amount of processing as opposed to a vector where it very much matters where we're going to be eliminating things. So what I can do here is I can say, and I want to eliminate from F, and I can say f.erase, and I have to give it a range. One of those things. Get what is the beginning and what is the end. And what I can say is I need to know f.begin because I'm trying to eliminate all the odd values which are on the left-hand side of this list at the moment, and I want to go up to iter, but not including. And this will do it. And oops, I just have to restart my program. And now you see all the odd numbers have been removed and all the even numbers remain. And so, so basically 2 lines of code as opposed to how would you write this? And I can even go ahead here. This is simple enough. Oh my God, what is he doing? I could use what's called a lambda. I know we're not officially allowed to teach lambdas, but I can say, I can basically just, if you've worked with anonymous functions in other languages, it's just a different way of doing it. And all I have to do here is just return is x and 1 equals 1 here. And if I did this right, you get the same exact result as we did before here, and we do. Boom, boom, boom. So it's one of those things, if this is like a one-off, this is basically in place of the function up above. You can just, basically you could just supply it inline and just say, uh-oh, and what is this? Oh, if you really want to, yeah, you gotta sometimes, the operations, this is why we use, I put a lot of parentheses in, more than you probably think I should, but there are times where you can get very weird compiler warnings if you're not careful. That gets rid of that warning at the very least. Yep, I got no warnings at the moment. And now I've gone ahead and I've eliminated all the odd numbers after I used a partition. you can see the power in the partition because you can supply any rule. Like data goes in and true false comes out. And so, you know, and you can actually supply things from, that's what these square brackets are for. You can supply variables that are part of main instead of just only supplying X and working with X. I mean, it's very powerful what you can do with it. And you don't have to write the code because the standard template library does it faster, better, and everything else for you. Okay, so we're getting closer here. So let's see. We already did this. Let's do this for the first 50 numbers instead of the first 30 numbers down here for H. I feel like I've used H, but I guess I haven't. Just been staring at all these letters all day. And H, H, H. Okay. And now we're right back where we were. Now we have the first, oops, that only does the first 30. I got to go back and fix this up for the 50. This will probably overflow into the next line because there's a lot going on here. There's H all the way from 1 to 2500, from 1 squared to 50 squared. So now H holds that, and now we only have 1 or 2 things left to do, and then our homework assignment is. Okay, so 2 last things to do. The second one is simple since we already know how to go. We just can basically I can do it right now. We just need to find an iterator because we're going to be creating another partition. But we're going to say, okay, H, erase everything from the beginning to that iterator when you find it. So I can borrow this. Again, I can borrow this for both. This is just a little more complicated because the statement inside of here is just going to be a little different. Because we're going to sort by even or odd and then from high to low. So it's like it's a 2-step process here. So give me a second here to set everything up. So I want to get my partition, and for the moment, what do you say? Like if I just do this right here, h.begin, h.end, begin, h.end, and say I'm partitioning again. I just want, if I can get myself to the same spot as I did with F, and then all I really, because I already am breaking things up by left to right. I'm sorry, from even to odd. It's already doing that. And I don't, in this case, I do not have to redefine iter because it already is a list int iterator. So this goes ahead and removes all the odd values from the linked list. And so again, this is slightly different. This time around, it's saying to put evens to the left and odds to the right. And this one, did it say anything about that? I guess maybe it didn't. But if I want, I don't have that function anymore because I got rid of it when I did this kind of stuff. But now if I wanted to, I could go ahead and say, okay, move, instead of doing this, say, oh, I do already have it here. Too much talking and not enough thinking. And so now I can split things up so that the even numbers go to the left. All I had to do is change that 1 digit inside there. And you can see that here because 4, 16, everything that's even starts here. And then starting here is where all the odd numbers pop up. And so I just switched things around doing that. And so now the final thing to do, because I've eliminated all the odd numbers. Oops, I've eliminated all the odd numbers. And I do have to fix this up on this end when I get here. I have to say, now that I've switched up the way we partition, I have to go ahead and say, now get me from where that iterator is to the end. Because I was eliminating the wrong list now. And now at the end of the day, I have an even, the even list is printed out. And you could, at this point, you would go, but it's perfectly fine. But I tried to add this. And again, I already did this for your homework assignment. I already put it out into the world, so I can't change it. But to say that, what would happen, let's say, I guess I won't do it. I'll just call this a day. But the thing is, I won't take any points off or anything but what if the list wasn't sorted? You know, what if I randomized everything? So like how, you know, so all even numbers move to the left, all odd numbers move to the right, but then we resort a second time. And so it gets a little trickier when you're dealing with that kind of stuff. Just because, like, if I come up here, and I go ahead and I say std random shuffle. And now, oops, that's a lowercase r. And I can say h dot begin and h dot end. And then I run this, you can see that now things won't be sorted. Oops. There's another thing you might see, and this is the fun of the standard template library. Like, can you believe that's C++? I can. Sometimes it's very hard. And there's a man named, I think, R.J. Pluger, his name. It's down here at the bottom. It's usually down here at the bottom, where it can say that he wrote the code. I guess this is not part of his work, or maybe it is, maybe it isn't. Usually he works with this. But what's happening here is they're and you're like, oh my God, what's wrong? And I guess you can't use random shuffle, just the generic random shuffle algorithm on a list, because a vector is random, a list is not so random. Like in a vector, I can say, get me the 12th element, and it'll do it just fine. In a list, I can't do that because everything is just linked together much differently than before. So all these this function doesn't work. And that's why for things like, we find it, where was it earlier? I feel like we did it already. Like unique and merge and even sort. Like you have to go ahead and use the list version of sort. So if there is no sort, I'm sorry, there is no random for this, then, nope, there isn't. You really can't go ahead and do this. Sort, reverse, resize, remove, push, pop, front, in place. Nope, there's no way to do this, and I can't show it off. You would have to write your own function. All right, everything up and describe how you always want. So I do have access to this how to shuffle a list, and it just gets a little more complicated. You have to use MT19937, these a different way of generating random numbers than rand. You have to use that number generator as part of the shuffle, not just random shuffle, but shuffle. It is possible to do it without having to write your own code. And so that's not the biggest. But what I wanted to show you here is basically that this little guy right here, just by itself won't solve anything. So I set this up so that it randomizes, instead of randomizing the values, or randomizing, and shuffling the thing around, I randomize the numbers that get placed into the thing. So here you can see just a bunch of random numbers. There's even, odd, even, odd, and so forth and so on. So they're all over the place when it comes to what x squared is. And I print it out. But then you notice my stable partition, it basically goes ahead and moves all the even numbers to the left and all the odd numbers to the right. And then the next step is to eliminate all the odd numbers. That's basically what we're doing. But you see that we said here that all the evens are sorted high to low, and all the odds are sorted high to low, and that's absolutely not happening. 36 is right in the middle of two large numbers. There's no way that this is going to work. It just so happened to work because when we went to do this earlier, everything was sorted because it was a stable partition. So the way around this, instead of using stable partition to make this work, we basically have to use a sorting function and then maybe find out where the stable partition is, or where that partition point is. Or let's say there's always different ways to do this. I just want to say it's not always just, ooh, there's an algorithm for this. Snap my fingers and get it done. Let me just wave my hands here to finish this thing up and just go, okay, just follow along, and you can do a little more research if you're looking into this. So I said this is a little more complicated, made it a little more challenging because I have to use sort because I can't necessarily use partition. So it's more because this is more of a sort than just so breaking things up into two places. It'd be a lot easier if I could pass in two things, but I need to sort. So I use this sort two ways function. And the sort algorithm requires me to create a predicate that has two parameters, basically an LHS and an RHS, because it's going to be doing a lot of comparisons, right? Because it's sorting things. Go, hey, are you less than? Hey, are you greater than? Whatever it is. But this is what we were saying about this, that all even numbers have to go to the left, all odd numbers have to go to the right, and then all the even groupings and all the odd groupings are sorted high to low. So this is to say, I need to figure out for both values their evenness. And if one is even and the other is odd, doesn't matter whatever it is, then we need to make sure that the even number goes to the left. And so if A is even and B is not, we return true because it is sorted. Because A is even, B is not, A goes to the left. So yes, return true. If the opposite is true, where A is odd and B is even, then B needs to go to the left. So it's not sorted the way it's set up, and then it returns a false. But the other two cases would be that either A is even, B is even, or A is odd, B is odd. And so we've fallen through the first criteria, and then we just return, is the A value larger than B? Whatever this ends up being, the Boolean here is returned from that operation. And so this function sorts the entire thing that way. And if you don't mind all this other stuff, let me just show you. I'll show you how this works here in a second. But you can see when we get to this step here that we go from everything just being randomized to everything being sorted, where all the even numbers are on the left-hand side, all the odd numbers are on the right-hand side, but everything is sorted from high to low inside of those two partitions as we set them up. They're everything from high to low on the even side, everything from high to low on the odd side. So then the final step is I need to eliminate the odds. So all I'm doing is looking for the first odd. I'm using the find if algorithm. And I'm just saying, hey, let's go through the entire H list. Find me the first odd. Basically, I'm doing my own partition. It's unfortunate that I have to use, I have to kind of go above and beyond to not use stable partition here, because it's just, there's no way to use it with a 2-parameter function, because stable partition is only looking one value at a time. So anyway, coming back, so find me the first odd value, and then go from there and erase from there to the end of the list, because I've already sorted it properly. And so that's how you end up with exactly what we were expecting to see here, where essentially we go from here, which is everything with evens on the front end, odds on the back, to eliminating, finding that first odd value, and then eliminating everything from there to the end of the list. And now all the even numbers are in there in sorted order. So that pretty much covers everything I wanted to do here. I don't know if I'm allowed to. I don't want to. This is one of those times where, do you want to put this entire thing, even if you could, inside of, use this as a lambda? I don't think so. But do I want to find out? No, I don't want to find out. I can find out on my own if a lambda would work for that. But again, the standard template library is there to help you. It takes a little time to get used to, because a human developed this. You have to follow their rules to get the thing to work. But once you have it working, you don't have to think about all those details. I just had to think about which algorithm can I use to get the job done. I didn't have to go back to my computer science upbringing and remember how to do a linear search and then how to sort and all these other things. We teach you that here. We teach you here at this level so you understand what's going on under the hood. When you get to be out in the field, you want to find efficient ways to do things. You don't want to just completely rely on linear search. I think there was a homework assignment you guys did, or an exam problem, where if you did it linearly, the thing would take minutes, if not more. But if you used a binary search, the thing could only, you could work it down to 30 seconds or so to find your answer. And that's what you want. You don't want your program taking days to find out something that should take a mere second or even less than a second. You want to be efficient in the way you do things. So, and the standard template library is there to help. It's not the end-all be-all. It's not the 100% cure for all of this stuff, but it definitely can get you most or part of the way. So as always, if you have any questions or concerns, if I said something wrong, I feel like I've been mumbling a lot this one, please get me at swardb@cud.edu, or you can get a hold of me here in the YouTube comments, and I'll get back to you and I'll correct any mistakes I made. Nothing here is, of course, intentional. Trying to explain this is hard enough. So thanks for sticking with it as always, and we'll see you next time. Have a good one, everybody.